Hi and welcome to 2019 paper 2 of the Junior Cert Higher Level. This is question 3. So as always, if you want a copy of the notes I'm working off, just send me an email at shanetroy@gmail.com, and that email address should be in the description below. So question 3 here is only worth 10 marks, fairly short the time frame you're given. Personally, I'm saying it here, I'm not the best with spatial reasoning stuff, okay? But practice, like everything else, makes perfect. Okay, so let's read through it. The coordinate diagram below shows the screen of a digital clock at 1500 hours, so 3 o'clock. Okay, so it's in the fourth quadrant. Okay, it's the x will be positive and the y will be negative. Okay, so it's going to move around. You have to just identify whatever's happening here. So the images P, Q, S, and T of the screen under 4 transformations are as follows. So you have P, Q, S, and T. So how will this change as it goes through under different types of symmetry? You're asked to complete the table below to match each image to the transformation that produced it. Use each letter P, Q, S, and T only once. Okay, so you have the table there. Which one, P, Q, S, or T, is axial symmetry in the x-axis? Okay, so if you can see that I'm taking that point there, okay, bringing it onto the x-axis straight on, okay, and maybe somewhere here. Now I'm using the mouse, this is hard to do. So this point here comes up and on the same distance again. That's your 1. If you can imagine the 5, the line would end up, yeah, each is on the same point, something like that. Okay, and then now the zeros won't look like they're different. Okay, now if you can imagine that, this random looks like that. That looks like S. Okay, I have the answer here. Yeah, so that's S. Now axial symmetry in the y-axis. So this is going to come this way. This is the y-axis. It's going to go on to the axis the same distance on again. So that's the 1. Now the 5 is going to flip around. Look something like this. Okay, I apologize for the mouse is just really hard to control. And then the 0, 0. Okay, it would be whatever over here. So if I'm not mistaken, that's that one. Okay, so that should be T. Okay, phew. That kind of took a sneak at the answer there, but we should always try these before we're looking at the answers, if you have the notes, okay, because it's making the click that's important. Now the next one. S, translation. Okay, so you're moving something through a point. Okay, what's going to happen to it then? Now, you might try look at the last one here. If each answer is only used once, and central symmetry in the origin. Okay, this point goes on to here, goes up the same distance, 1. Then this would end up, if I had a marker, that would be there. This would go on. Q? No. Oh, sorry, it would be Q. Yeah, central symmetry. Okay. So I'm trying to, in my own head, I'm trying to visualize that. So that would be Q, okay, which means the translation would be, well, T, not T, P. Okay, now P would be this one here. Does that make sense? Oh yeah, so translation is just moving it around. Okay, so just moving it wherever. It will look the exact same. Just now to think about it easier. So that's the answers taken from the marking scheme, okay? You could guess it. Okay, there's 10 marks. If you got 1 right, you'd probably get 2. If you got 3 right, you'd probably get 7. So look, no reason in the world we guessed that you couldn't get 1 or 2 things. Anyway, we'll keep it short. That's question 3. That's the only part of it. So see you on question 4. Thanks very much.